Welcome to Daily AI Brief. In today's episode, we're diving into the latest groundbreaking developments in artificial intelligence. From enhancing robotic navigation with fewer sensors to redefining AI model architecture, we'll cover a range of innovative solutions shaping the industry. Sit back and get ready to explore the transformative world of AI, where technology meets real-world applications. Mistral AI is redefining the landscape of robotic navigation with its latest release, Robostral Navigate, an 8 billion parameter model designed to help robots navigate complex environments using just a single RGB camera. This model significantly reduces hardware complexities, moving away from traditional multi-sensor systems. Detailed breakdown. Simplifying sensory inputs. Robostral Navigate utilizes a single RGB camera for navigation, a departure from the multi-sensor array traditionally needed, such as LiDARs and depth sensors. This shift dramatically cuts costs and simplifies robot design by eliminating the necessity for these additional components, which can be expensive and bulky. Technological innovations. Single RGB camera focuses the entire navigation process on inputs from one camera, relying on advanced data processing to maintain high accuracy and effectiveness, reducing sensor calibration challenges and expenses. Edge hardware compatibility. The ability to operate offline is pivotal for environments where internet access may be limited or unreliable, such as warehouses or remote areas, further enhancing its utility in diverse field conditions. Multi-robot versatility. Whether it's a wheeled robot in a factory, a legged robot navigating rough terrain, or a drone flying overhead, Robostral Navigate adapts seamlessly, offering broad utility across different robotic frameworks. Training and benchmarks. The model was trained on approximately 400,000 trajectories derived from 6,000 virtual environments. This extensive training dataset ensures robustness and adaptability. Achieving a 76.6% success rate on the R2RCE benchmark, it surpasses traditional models by 4.5 percentage points, ensuring reliable operation in unseen and complex environments. Moreover, its performance in simulated tasks is noteworthy, achieving a 92% success rate in standard pick-and-place operations and an 87% success rate in dynamic obstacle avoidance scenarios. These benchmarks highlight its potential to outperform existing navigation models that rely heavily on multiple sensory inputs. Practical considerations. What to try? Potential users can experiment with Robostral Navigate through various simulated environments available on Mistral AI's official website. This can serve as a foundational playfield for those looking to delve into advanced robotic applications. Users interested in customizing Robostral Navigate may attempt fine-tuning the model on specific tasks using incredibly small training datasets, sometimes as limited as 500 examples, demonstrating the model's efficiency and flexibility. Trade-offs and unresolved challenges. The transition to real-world application remains challenging. Factors such as variances in lighting conditions and camera intrinsic settings can impact performance. Comprehensive field testing will be pivotal to overcome these challenges, especially in unpredictable environments. Integrating Robostral Navigate into existing robotic ecosystems might encounter unforeseen complications. Detailed documentation on integration practices and adaptability will be essential to facilitate widespread adoption. Conclusion. Robostral Navigate represents an influential shift towards more efficient and accessible robotic navigation solutions. By reducing reliance on complex sensor systems, it promises to democratize autonomous technology deployment. As industries explore this innovative path, the model could set a precedent for future advancements in edge-efficient, camera-focused navigation systems, propelling a new era of innovation in robotic automation. On June 30th, 2026, Anthropic released Claude Sonnet 5, marking a significant upgrade in AI model capabilities. Known for improved efficiency in coding tasks, this model is a step forward in autonomous planning and tool usage, particularly in coding environments. Claude Sonnet 5's introduction positions it directly against Anthropic's own Opus 4.8, providing a more cost-effective option for businesses aiming for budget-friendly AI solutions. The introductory pricing at $2 per million input tokens and $10 per million output tokens, valid until August 31st, 2026, underlines this affordability. This pricing is set to rise to $3 and $15 respectively after the introductory period. A key technical focus of Claude Sonnet 5 is its enhanced agentic capabilities, which include sophisticated autonomous planning and increased tool usage efficiency. These capabilities allow the model to handle browsers and terminal integrations with unprecedented precision, thus enhancing the AI's application in complex coding environments. The advanced algorithmic structures underpinning Claude Sonnet 5 bolster its reasoning skills, making it adept at managing intricate tasks that require nuanced problem-solving approaches. The optimized architecture of Claude Sonnet 5 significantly boosts its performance over extended tasks, which is crucial for enterprises looking to deploy AI in real-time applications. The model's APIs are engineered for seamless integration with existing production systems, facilitating rapid deployment and reducing time to market for new developments. Numbers and benchmarks. From a performance standpoint, Claude Sonnet 5's enhancements aim to closely rival those of the higher-tier Opus 4.8, with a claimed improvement in coding output while maintaining cost efficiency. This performance metric aligns with Anthropic's aim to cater to businesses that require high-level operations without the corresponding high expenses typically associated with advanced AI models. Trade-offs and limits. Despite these advancements, potential security concerns have been raised, notably regarding alleged backdoor vulnerabilities that could compromise sensitive data. This poses a significant consideration for enterprises that prioritize data security. Furthermore, transitioning from earlier models like Sonnet 4.6 could entail a learning curve, impacting teams' adaptability and initial productivity. What to try this week? For developers eager to explore Claude Sonnet 5's capabilities, visiting Anthropic's official website will provide in-depth release notes and documentation. Users can test the model using example commands to gauge its coding enhancement features. Exploring the API integration options with real-world coding tasks can also provide insights into how this model could streamline development processes. In conclusion, Claude Sonnet 5 presents a robust option for enterprises seeking to enhance their AI capabilities in coding at a lower cost, although considerations about security and user adaptation must be taken into account. OpenClaw's recent transition to a nonprofit foundation signifies a pivotal moment in AI development philosophy. By rebranding itself as a neutral platform, OpenClaw aims to foster open collaboration without the influence of corporate interests. This shift not only marks a structural change, but also aligns with a broader vision of democratizing AI technology and ensuring its ethical evolution. Growth and popularity. With its impressive traction, OpenClaw has seen 4.5 million weekly installations due to its innovative autonomous coding and task chaining capabilities. These numbers underscore the widespread appeal and utility of its open-source framework within the AI community and beyond. The foundation, now recognized as a 501c3 organization, benefits from increased trust and credibility, attracting more developers keen on contributing to a neutral, communal AI platform. Community-driven contributions. OpenClaw operates on an open-source model, allowing free access and modifications. This approach enhances creativity and innovation, drawing talent globally to collaborate on AI projects. Interoperability standards. Part of its mission involves creating standards to enable AI agents to work across different platforms. This interoperability is crucial for integrating AI into varied ecosystems, fostering a seamless mix of AI technologies without vendor lock-in. Security and sustainability. Strengthening the code base is a priority. By addressing vulnerabilities and encouraging sustainable development practices, OpenClaw aims to maintain robustness in its software offerings, ensuring long-term reliability and protection against cyber threats. Challenges and considerations. Neutrality and balance. Maintaining true neutrality requires navigating complex governance issues, ensuring that collaboration remains unbiased among stakeholders with potentially conflicting interests. Funding and community engagement. Sustaining its operations hinges on consistent funding and active community support. As a nonprofit, it must regularly align resources with goals to meet the community's expectations and technological advancements. Trade-offs and limits. Despite enthusiasm about its nonprofit status, potential challenges include reconciling diverse stakeholder perspectives and ensuring the continuous engagement of contributors. These factors are critical to its developmental trajectory and overall success. What to try this week? Community engagement. Visit OpenClaw's official website to explore resources, participate in collaborative projects, and contribute to ongoing developments. This is an opportunity not only to enhance personal skills, but also to influence the future paths of AI technology. Takeaway: OpenClaw's transformative approach represents a significant shift toward ethical, community-driven AI development. Its success could influence how future AI initiatives are structured, potentially encouraging widespread adoption of similar nonprofit frameworks. Engaged stakeholders and contributors will be the driving force behind creating a trusted, inclusive ecosystem that aligns with the needs of a rapidly evolving AI landscape. NVIDIA's latest advancements in domain adaptation through the Cosmos 3 platform represent a significant leap in model accuracy for video question answering tasks. By incorporating Tau agent skills and LoRa post-training methodologies, accuracy improvements have soared from 54.41% to an impressive 93.35%. This growth in performance is facilitated by NVIDIA's strategic implementation of Tau, train, adapt, optimize agent skills, which automate critical processes such as dataset handling, baseline evaluations, and hyperparameter optimization. Such automation not only minimizes the need for manual intervention, but also accelerates the entire model adaptation process to less than a day. Technical drill down: Tau agent skills. These skills are designed to streamline and automate routine operations, allowing developers to focus on higher-level strategic planning rather than manual tasks. The automation of dataset handling and hyperparameter tuning is crucial for achieving rapid deployment, especially in environments requiring swift model updates. 2. LoRa configuration. LoRa, or low-rank adaptation, significantly enhances training efficiency by adjusting model weights with minimal computational resources. This technique is instrumental in maintaining high model performance while reducing overhead, increasing training speeds, and keeping hardware requirements low. 3. Mixture of transformers architecture. This architecture is adept at processing multimodal inputs, such as text, images, video, and audio. By supporting diverse data types, this system merges reasoning and generation pathways, enabling more sophisticated and nuanced model responses. Numbers and benchmarks. The accuracy boost from 54.41% to 93.35% showcases a 38.94% improvement, reflecting Cosmos 3's capability to elevate model performance significantly. This leap in accuracy was achieved on the woven traffic safety dataset, a benchmark known for its complexity in video question answering. Cosmos 3 employs the Reasoner NIM, Neural Interface Module, to deploy trained models via OpenAI-compatible endpoints. This compatibility reduces the intricacies of traditional infrastructure setups and mitigates dependency on CUDA, further simplifying deployment and scale. Trade-offs and limits. While internal tests report substantial accuracy improvements, external validation across various datasets is needed to confirm these results universally. The model's scalability for large-scale applications, especially outside NVIDIA's hardware ecosystem, remains to be fully evaluated. Another consideration is the reliance on NVIDIA's proprietary technologies, which could limit the flexibility for organizations wanting to diversify their tech stack. However, this integration undoubtedly offers a cohesive environment for those within the NVIDIA ecosystem. Practical steps to consider. Review the technical documentation, docs.nvidia.com's cosmos/latest transfer 2.5 post-training index.html utim source open on post-training methods to gain insights into leveraging Tau agent skills for specific use cases. Experiment with model evaluations through the Cosmos 3 Reasoner NIM, considering potential deployment as OpenAI-compatible endpoints, especially if minimizing operational overhead is a priority. NVIDIA Cosmos 3's enhancements in post-training methodologies position it as a powerful player in the AI domain adaptation landscape. offering both efficiency and enhanced model performance while raising questions about generalizability and ecosystem dependence. Microsoft's introduction of the May I Thinking One model signifies a monumental step in AI development with the use of an innovative mixture of experts, MoE architecture. This model boasts 35 billion active parameters within a framework of 1 trillion parameters, showcasing Microsoft's dedication to creating pioneering proprietary AI solutions. The May I Thinking One model pursues a systematic approach to AI development, emphasizing system-level optimization. The report details how this approach results in more efficient AI systems by optimizing each component, from data processing to model integration, ensuring that every part of the model is finely tuned for maximum performance. Furthermore, Microsoft's reliance on clean enterprise-grade data precludes model distillation from third-party datasets, potentially increasing the model's reliability and transparency. This model presents outstanding performance metrics, such as 52.8% on the SWE Bench Pro, 97.0% on AME 2025, and 87.7% on LiveCode Bench v6. These benchmarks highlight the model's potential in various AI applications, yet they require further independent verification to confirm these formidable claims. Such verification is crucial as it decides the acceptance of these metrics within the AI community and potential enterprise adoption. Technical drill down: mixture of experts architecture. This unique design allows for selective activation of parameters based on the specific task at hand. It ensures that only the required parameters are activated, optimizing processing power and improving efficiency. This contributes significantly to the system's ability to tackle a variety of tasks with precision. System-level optimization. The model uses a holistic framework that integrates development and deployment as interconnected processes. By treating these stages as a unified entity, May I Thinking One minimizes inefficiencies and enhances overall model performance. Enhanced reasoning capabilities. May I Thinking One integrates advanced reasoning skills while including built-in safety features crucial for deployment in sensitive sectors like healthcare and finance. Trade-offs and limits. Despite its promising technology, the model's reliance on proprietary data could restrict replication and hinder adoption in more diverse contexts. Moreover, the significant computational resources required to train such a large MoE model may be prohibitive for smaller organizations, posing a barrier to entry in the deployment of similar AI solutions. What to try this week? For those interested in further exploring this model's potential, the official technical report available on Microsoft's website is a vital resource. It provides comprehensive details about the methodology and architectural strategies employed in the development of May I Thinking One. Conclusion: the development of May I Thinking One not only marks a strategic pivot for Microsoft towards proprietary AI endeavors, but also sets a precedent in transparency and system-level optimization in AI research. As the benchmarks are independently validated, this model may redefine enterprise AI landscape, proving instrumental in the advancement of AI-based decision-making tools and applications across various industries. NVIDIA's Ising Decoder is revolutionizing quantum error correction, showcasing over 300x improvement in logical error rates for quantum computing. This innovation, integrated with NVIDIA's CUDA-Q and NVQ-Link, aims to enhance error correction using a 3D convolutional neural network model. This development is crucial as effective error correction remains a bottleneck in practical quantum systems. Reducing the required training dataset to just 1/10 that of its predecessor, while simultaneously tripling accuracy, showcases the technology's efficiency and potential impact. Such efficiency can facilitate the scaling of quantum processors, making reliable quantum computation more accessible to diverse applications. Technical drill down. 3D convolutional neural network model. This advanced architecture processes spatial data to optimize error decoding. Utilizing 3D convolutions helps in understanding multidimensional data relationships, essential for identifying and correcting errors in complex quantum data streams. Integration with CUDA-Q ensures efficient deployment on quantum GPU supercomputing platforms, utilizing NVIDIA's robust parallel processing capabilities. This integration accelerates the processing speed by 2.5 times compared to traditional pi-matching decoders, enabling real-time error correction. Modular approach. By utilizing pre-trained models and offering tunable guidelines, users can adapt the decoder to specific quantum tasks. This modularity means that the Ising decoder can be tailored to various quantum error correction scenarios, making it highly versatile. Numbers and benchmarks. Logical error rate improvement. Over 300x compared to prior decoders, which is a groundbreaking leap that could drastically reduce computational errors in quantum systems, thus increasing the viability of practical applications. Speed and accuracy gains. The decoder processes error correction data 2.5 times faster than existing models, with a 3x increase in correction accuracy, setting new standards for performance in the field. Trade-offs and limits. Validation across quantum systems. While the Ising decoder shows great promise, its performance across various quantum hardware remains to be fully validated. Different quantum systems and noise models may pose unique challenges, requiring further adaptation of the decoder. Adaptability to diverse environments. The ability of the Ising decoder to generalize its performance under different operational conditions and noise levels needs thorough investigation. What to try this week? Practical implementation and experimentation. By accessing the models available on platforms like GitHub, users can begin integrating the Ising decoder using NVIDIA's CUDA-Q framework. This hands-on experimentation can help understand practical deployment challenges and benefits. Takeaway: the Ising decoder marks a turning point in quantum error correction, significantly boosting both accuracy and speed, crucial for advancing quantum technologies. Its efficiency and open availability pave the way for global collaboration and potential breakthroughs in quantum computing applications. With increased error correction capabilities, the future of quantum computing is poised for unprecedented growth and exploration into new technological frontiers. Blume, an open-source zero-config documentation framework, is revolutionizing the landscape of documentation creation and maintenance. By offering AI-ready documentation generated directly from Markdown files, Blume simplifies the process for developers, allowing them to concentrate on their actual content rather than the technical complexities of setup and configuration. Breaking down Blume's capabilities. Blume leverages automation to produce documentation with intelligently inferred features such as navigation, search, and theming. The framework excises traditional configuration hurdles through its integration with modern web technologies like Astro and Vite, which ensures rapid build times and seamless integration with various content sources. Markdown processing. This core feature involves the automatic transformation of Markdown files into fully fledged documentation sites. By interpreting Markdown syntax, Blume can auto-generate site elements and functionalities that enhance user interaction while eliminating manual setup steps. Architecture and build tools. At the heart of Blume lies Astro, a static site generator that excels in creating optimized, lightweight documentation sites. Vite contributes with its blazing fast bundling capabilities, facilitating an efficient development and production process. Together, they form a potent duo that underpins Blume's performance efficiency. API and integration flexibility. Blume provides versatile APIs that allow users to interface with a variety of content sources, ranging from local files to remote repositories, without extensive setup. This adaptability is crucial for fitting into diverse workflows and content management systems, CMS. While precise performance metrics remain unspecified, Blume's zero-config design is engineered to drastically cut down setup time, a critical advantage for teams with limited resources. Users can expect significant time savings, although the exact numerical impact is yet to be quantified. Trade-offs and challenges. Despite its promising features, Blume faces certain challenges. As a new entrant, it must contend with questions about its long-term viability and community support. The effectiveness of its feature set and extensibility compared to established frameworks like Docusaurus or MechDocs remains unproven. Furthermore, its zero-config promise could be challenged by scenarios that necessitate manual intervention for unique project needs. Practical steps to engage with Blume. To explore Blume's potential, visit the official Blume website, h//useblume.dev/OpenAI, and try initiating a project using the command X Blume init. This hands-on approach will demonstrate Blume's capacity to infer settings directly from your Markdown files, showcasing how effortless starting a documentation project can be. Conclusion: Blume's zero-config paradigm represents a bold stride towards enhancing documentation efficiency and accessibility. By shifting focus from configuration to content, Blume stands to significantly alleviate documentation burdens and encourage broader usage of automated documentation processes across industries. NVIDIA is pushing the boundaries of machine learning research with its groundbreaking Autoresearch workflow, now seamlessly integrated within the NeMo framework. This advancement caters to the increasing demands for automation in machine learning tasks, specifically aimed at minimizing manual labor and enhancing the efficiency and efficacy of long-duration ML experiments. NVIDIA's workflow is anchored by three pivotal functionalities: full-stack autonomy, goal-driven auto-research, and paper-to-code translation. These elements collectively serve to reshape the research landscape by leveraging automation for greater efficiency. The integration of advanced tools like NVIDIA's Codex with GPT 5.5 is central to this process, facilitating more strategic decision-making and expediting result iteration. Technical drill down, full-stack autonomy. This capacity involves managing complex technical requirements such as software setups, GPU memory allocation, and continuous experiment monitoring. By automating these aspects, researchers can avoid common pitfalls related to resource management and ensure a smoother workflow. 2. Goal-driven auto-research. This component automates critical research functions, including the profiling of baselines, launching of experiments, and thorough metric analysis. It iteratively refines research objectives, ensuring that each step is informed by the most recent data and outcomes, thereby optimizing the research trajectory. 3. Paper-to-code translation. This innovation translates research papers into actionable implementation plans and generates corresponding code swiftly. It initiates validation training, significantly reducing the time from theory to practice. Numbers and benchmarks. The framework robustly supports models containing up to 32 billion parameters, a striking feat that enhances its scalability across diverse research settings. This capability is crucial for handling large-scale AI models effectively. By incorporating Megatron Core, the workflow offers optimized training throughput, which is essential for scaling up models efficiently. This ensures that resource utilization is maximized, accommodating ambitious machine learning experiments. Trade-offs and limits. Although revolutionary, the integration of NeMo RL presents challenges, particularly within existing enterprise infrastructures. This may require organizations to upgrade their systems or acquire specialized expertise, posing potential barriers to adoption. The rapid evolution of AI tools also raises questions about the long-term support for NeMo RL components. Researchers may need to continuously adapt to maintain compatibility with new technologies. To dive deeper into this workflow and explore its implementation, check out NVIDIA's detailed blog post on setting up the framework and potentially transforming your ML research capabilities. Takeaway: NVIDIA's auto-research workflow is poised to redefine machine learning research methodologies by significantly reducing the time researchers spend on repetitive tasks. It enables more focus on strategic objectives, fostering faster iteration cycles and enhancing productivity. The overarching aim is to accelerate the deployment and management of large-scale AI applications, potentially ushering in broader integration of RL-driven workflows across various AI research domains. A recent study by the National Bureau of Economic Research, NBER, uncovers a striking finding. 89% of executives report no observable productivity increase from AI investments, despite its widespread implementation across various sectors. This statistic highlights a significant gap in aligning AI initiatives with tangible business outcomes, prompting a reevaluation of how AI productivity is measured. The study suggests a shift beyond traditional metrics, such as token consumption, towards developing a comprehensive framework that encompasses both technical efficiency and human-centric aspects. Integrating AI into daily workflows is proposed as a strategy to better capture its true impact on business operations. Technical drill-down methodology. The study engaged 6,000 executives from multiple countries, providing a wide-ranging perspective on AI's influence across different markets and sectors. This robust sample helps ensure that findings reflect a broad spectrum of experiences and insights. Sector-specific factors. AI's productivity impact is not uniform. It varies significantly across industries and organizational sizes. For example, technology and finance sectors may see different outcomes compared to manufacturing or logistics due to inherent operational differences. Tailored strategies are crucial for maximizing AI's potential within specific sectors. Holistic measurement framework. By advocating for AI integration into workflows, the study suggests a method to bridge the gap between technology deployment and business outcomes, emphasizing that success should be measured in terms of both technical advancements and enhanced human interaction. Numbers and benchmarks. Executives anticipate a modest 1.4% productivity increase and a 0.8% rise in output over the next 3 years. These forecasts highlight cautious optimism and underline the need for strategic approaches to realize such gains. The report of 40,000 job losses in Q1 2026 due to AI-driven automation serves as a stark reminder of immediate labor market effects and the importance of balancing technological advancements with workforce considerations. Trade-offs and limits. Discrepancies in productivity results can arise from industry-specific challenges, underscoring the necessity for sector-based analyses. Without addressing these variances, companies might not fully realize AI's potential or may misalign their expectations. An over-reliance on purely technical metrics without considering broader business impacts might skew understanding and decision-making processes, leading firms to potentially misguided conclusions about AI's effectiveness. What to try this week? Investigate frameworks that measure AI's comprehensive business impact, looking at successful case studies such as those highlighted by the NVIDIA. These could offer insights into effective AI integration strategies that align with broader business goals. Takeaway. Embracing a multidimensional approach to measuring AI productivity is essential for organizations to glean meaningful business insights. By focusing not only on technological efficiencies but also on strategic business impacts, firms can better navigate AI's transformative landscape and ensure that investments yield genuine value. That's a wrap on today's episode of Daily AI Brief. From robotic navigation innovations to groundbreaking AI research methodologies, we've seen how technology is continuously shaping our future. Stay tuned for more insights into the ever-evolving world of AI. Don't forget to check the resources and try some of the suggested experiments this week to stay ahead in your AI journey.